Good evening, class. I hope everybody is doing fine. We are starting chapter 8, application of trigonometric functions, section 8.1, right triangle trigonometry applications. So in this chapter, we'll be dealing with right triangle trigonometry applications, and then we add to it the law of sines and cosines. So to do so, we need to remember all the basic trig identities that we have studied, from fundamental trig identities such as Pythagorean identities, or even an odd properties, or the reciprocals, and you name it. You've got to be very comfortable with those. The inverse functions, some difference, double angle, half angle formula. Some of the formulas you come across more often than the others. On a normal basis, when you know the formulas about sine and cosine, you can figure out the rest. Remember that, okay? So let me get rid of the video to make sure that, you know, it's easier to upload this stuff. And so we are moving towards this section. So let me put it in slide mode. All right, right triangle trigonometry application starts from here. And in short, we need to solve a right triangle. What do we mean by solving a right triangle? A right triangle can be solved, or just in general, a triangle can be solved as long as we have all the angles and all the sides. Okay, class? That's the meaning of solving a right triangle. So, let's see what we know already from before, okay, whether we had a trigonometry or not. Generally speaking, we use capital letter to represent the angles and lowercase letters to represent the sides. So let me use my pen here to show something. For example, if this is A, okay, this didn't work. You see that. If this is A, the way you name the side opposite that is the same with the lowercase, okay? And so, for example, this is capital C, and so the opposite side is the lowercase. Now, what do we know about the right triangle? Obviously, we know the Pythagorean theorem, a squared plus b squared equals c squared. We also know if it's a right triangle, the other two angles, okay, acute angles, that means angles that are less than 90 degrees, they must add up to 90, okay? So that's something we know, okay? The other thing is the definition of trigonometric functions we are going to repeat. And the main ones, again, are the sine and cosine, okay? Remember those. What is sine? Opposite over hypotenuse. What is cosine? Adjacent over hypotenuse, okay? So I hope everybody remembers that. Now, the rest you can follow that. Maybe you remember also tangent is opposite over adjacent. The rest of them are reciprocals. You can stick with the reciprocal and take care of the business. So there's really nothing brand new here. This is just to refresh everyone's memory. In short, we have three angles, okay? One of them is known to be 90 degrees. We have to figure out the other two. We know the sum is 90 degrees. And there are three sides we need to figure out, and knowing the relationship among those and trigonometric functions, okay? So let's start with this example, okay? We are interested in finding the value of each of the 6 trigonometric functions of the angle theta, okay? Knowing that one side is 3, one side is 5, and the opposite of theta is missing. So the very first thing is to figure out what is the side missing using Pythagorean theorem. So it's a squared plus b squared equals c squared that is being used. And let's say the opposite, we call it b, okay? And let's say this is a, and the hypotenuse is c. So we can just go through the process. This is a very simple calculation, and the answer is 4. I don't think anyone has any problem with that calculation, okay? That sounds good, everybody? Now, let's give everybody a moment. I'm gonna pause the recording a quick second, let's say 30 seconds, see if you can figure out sine theta, cosine theta, and the rest of it. All right, so let's start with the sine. Sine is simply opposite over the hypotenuse. Okay, so in this case would be, the opposite would be b, or 4 over 5. Does that make sense to everybody? And what about cosine theta is adjacent over the hypotenuse, 3 over 5. And I'm going to assume you can easily see the rest of them. So we discussed this one, we discussed this one, and tangent is, of course, opposite over adjacent, or sine over cosine. The rest of them, you just write the reciprocals. You just write the reciprocals. I hope it sounds good with everybody, so we can move on. Okay. We're going to go to the next example, and as always, class, if you have a question, you're more than welcome to stop me. Okay, I'm going to simply move on. Okay. All right. Now, we have the same situation. A bunch of stuff is given, a bunch of stuff is missing. In this case, A is given, B is given. And by the way, even if they don't give us a triangular shape, you can make up a triangular shape and put up the numbers. And even if they are not to scale, it is okay, class. You just write it down and then you figure out the scale. So A is given, B is given, and we want to find the missing stuff, okay? So again, I'm going to give everybody a chance to work on this. It's a simple case. I'm going to pause the recording. Okay, now, any ideas how we get this started, class? Anybody want to share with us how we do that?
So we find C by the Pythagorean theorem, right?
Very good, very good, very good. So that's perfect. That's a perfect start. And that's the answer so far. So we have all the sides, okay? Now we need to find all the angles, and obviously one of them is 90 degrees. So any ideas how we get there? How would you find A or B? Any ideas?
We can do.
We have 6 different trigonometric functions. Use any of it. Now,
either sine or cosine.
You can use any of them. My suggestion is look at what's given, because numbers 2 and 3 are given, you want to use them. And here's the reason, class. I want you to pay attention to what I want to tell you. This number we just came up with, right? And if for any reason we made a mistake, if we use that, every other answer we come up with is going to be wrong. Instead of using that, let's use what's given to us. And this way you can use tangent or cotangent for A or B, and it will do the job. So if you use tangent A is the opposite over the adjacent 3/2, or you can use the B, tangent, cotangent, it makes no difference. And so what is A is the tan inverse, and you do have to use a calculator at this point. Now, if you left it as that, it's a precise answer, okay? But we want to rough estimate 56.3 degrees. By the way, if they don't tell us how many decimals, 1 decimal for degrees is normally good enough, but you don't want to leave it as 56. That's not a good answer. And so what is B is 90 minus this. Now, if you wrote 90 minus tan inverse, of course, both of them are exact. There's nothing wrong with them. It's just that we most likely need an approximation. I want to move on to the next example. I hope everybody is following. Is there any questions, class? All right. So again, could we have used C, which is square root of 13, for example, sine of A or sine of B or cosine of A, cosine of B? Yes. But the reason I don't recommend that, maybe, you know, we made a mistake with our calculation. So let's stick with the given to be on the safe side, okay? So here's the next example. We have a right triangle, okay? A is 40 degrees. And we want to find the rest of them that are missing. In this case, B is 2, okay? So this is B, okay? We want to find A, C, and B. I'm going to give everybody a minute. I think by now you have enough practice. So I'm going to pause the recording so you can find this on your own. Okay. First and foremost, what is the fastest and easiest missing element we can find? Fastest. Anyone?
B.
B. That's it. Okay, because A plus B is 90 degrees, we can find B. And again, we want to use the given info as much as possible. Okay, sometimes it may not be. So now we want to get A and C. Any ideas how we get those?
We can use sine of B equals 2 over C, and then
One more time. What was it, please?
like sine of B, that is now 50 degrees, equals to
Okay. Now, here's the thing,
over
though.
C, or is there an easier way?
Remember what we want to do. We want to use the given.
Yeah.
Even
Okay, so we
50
can
degrees.
40.
I mean, you can do that. Understand, you can do that, and it works out. The reason I want to use the given, because in case somehow, even with an easy answer such as 50 degrees, somehow we are in rush, we may make a mistake. So let's not take a chance. So I hope you see that if I use the given information, tan of 40 is equal to what? The opposite,
over adjacent.
which is A, over the adjacent, which is 2. Okay. And what about cosine 40? Cosine 40 is the adjacent,
Adjacent over
is 2
hypotenuse.
over hypotenuse, which is missing.
Mhm.
So I hope you see what we are trying to do. We are hoping we can use the given information. Now it's very simple. You do the cross product in each case, and you come up with A and C. So A would be 2 times tangent 40, and with a couple of decimals, we get 1.68. C would be 2 divided by cosine 40. Okay, and that's about 2.61. By the way, when you find A, you can use Pythagorean theorem to come up with the answer. But don't forget what I said. I think the best course of action is to use what is given. Okay, class, that's extremely important. I really can't emphasize this enough, okay? And again, you'll see it. I mean, if for any reason you're taking the exam, you're in rush, something goes wrong with your calculation, you use the calculation that was wrong, everything becomes wrong. So don't take a chance. Use the given. Use the given. Everybody okay with that? We want to go to the next example. Okay. So we discussed this last time, the idea of co-functions. I mentioned it, and when we were looking at the relationship between sine and cosine, and we looked at using the sum and addition for the difference formula, sine of pi over 2 minus theta, or cosine of pi over 2 minus theta. I hope you remember that. We did that previously. And so what happens is that co-functions refer to the fact that if the angles are complementary, then we have some co-functions. That means sine of this equals to cosine of that. Tan of this is equal to cotangent of that. Secant of this equal to cosecant of that. And the most important thing is the sine and cosine, of course. And it's easy to see that from the figure, okay? As you can see, A and B, just if you look at this picture, A and B, they do add up to 90 degrees. So they are complementary angles. I hope you remember the definition of a complementary from geometry, okay? Even when we had algebras, we had some application problems regarding complementary angles and supplementary angles. Complementary means they add up to 90 degrees. Supplementary, they add up to 180 degrees. So with that being the case, if you are looking at just this triangle, okay, and if you look, I'm going to write this so you see how that works. Sine A. What is sine A? Opposite of A is what? Lowercase a over the hypotenuse, okay? Now, I hope you see that this is the same as cosine B. Do you see that, everybody? Cosine B is the adjacent to B, which is A over C. So right then and there, what this means is that if two angles add up to 90 degrees, we call them complementary. Sine of one equals to cosine of the other. And the same thing goes for tangent and cotangent, and secant and cosecant. Sounds good, everybody? So with that being the case, let's see if we can answer this question. Sine of 62 degrees, tan of pi over 12, cosine of pi over 4, cosecant of pi over 6. So I want everybody to have a chance to answer each and every one of them. We'll discuss them in a moment. All you have to do, think of the answer for each and every one of them. What's the answer for A, B, C, D? And we'll go over it in a moment. We are looking at complementary angles class, okay? Okay. Let's start with the first one. Sine of 62 degrees. It's equal to cosine of what? 90 minus 62. 90 minus 62. Therefore, it becomes cosine of 28 degrees. So this one is 90 minus 60. Okay. Does that make sense, everybody? Okay. Now the next one says, okay, what about tan of pi over 12? Tan of pi over 12. That is equal to cotangent of something. How do you find that? Pi over 2 minus pi over 12. So because this is pi over 12, we are looking for pi over 2 minus pi over 12. Is everybody clear? Instead of saying 90 degrees, now we use pi over 2. So what is pi over 2 minus pi over 12? The common denominator is 12, so this is 6 pi over 12 minus pi over 12 is 5 pi over 12. Okay. The rest is easy. Cosine of pi over 4 is sine of something. What would that be? Pi over 2 minus pi over 4. And that's sine of pi over 4. And you all remember cosine of pi over 4 and sine of pi over 4 are both of them square root of 2 over 2. Cosecant pi over 6, okay, is equal to secant of pi over 2 minus pi over 6. And you take a common denominator and you do the math and you end up with pi over 3. I hope you remember pi over 3 and pi over 6, they add up to pi over 2. So that's it. I think easy math. It's not a big deal. Sounds good? Is everybody okay with that? Is there any question up to here? I'm going to look at one more example and we take a few minutes of break. So I'm going to go to the next example. Before I do that, so everybody is comfortable with the concept of a co-function and what we mean by co-functions, okay? All right, of complementary angles. All right, I think we are doing okay. Let's go to the next question. Could somebody be kind enough to read this question for us, please?
How do you say that word? Sorry.
Where were we? Okay, a surveyor.
Oh, okay.
Yeah, go ahead, please.
A surveyor wishes to find the width of a river. He sets up his transit, an instrument that measures angles at sea on one side and guide it across to point A on the opposite side. After turning through an angle of 90 degrees, he walks 200 meters from C to a point B. And finally, setting his transit at B, he measures angles ABC,
Yes, perfect.
at 20 degrees. What is the width of the river?
Thank you so much. Class, I want you to see when you are dealing with applications, a lot of time, setting up the question is a lot more difficult than actually figuring it out. It's really not too bad. And setting up, you may or may not be given the diagram. You have to come up with that. But I hope you appreciate the type of applications. These are simple applications. There's a lot of applications for math, especially when you deal with cases like trigonometry. Okay, so here's a very simple example. Okay, you want to know the width of the river. How do you find it? Think about this. Isn't this amazing? I hope you're fascinated by this. Okay, I think it's amazing. Imagine you're on one side of a river and you want to find the actual width. There is a way to do that without really measuring the width using trigonometry. Okay, so again, the unit they use is called transit. Okay, it's an instrument that they use to measure angles. Okay, so basically he picks up or she picks up a couple of points. Okay, and it is important that if you're along the river, okay, you go straight along the river and the angle it should make to the line along the river must be a 90-degree angle. So this class, BC is along the river and AC is perpendicular to that. So that gives you almost a precise width of the river. I hope everybody's following that, okay? So now that we have set up this, we have, and of course, then we are 200 meters or some distance. It doesn't matter what the distance is, it's known, okay? Because we are on that side, we can do the calculation one way or another. So we are 200 meters away from the point C, and that's important to understand, which is perpendicular to this line BC, and therefore it can give us the width of the river, which is AC. So first, is everybody okay with the setup and how this thing works so far? Now,
Yes.
how would we find the width of the river? Any ideas? What would be the best course of action based on the given information? Any ideas? Take a look at the diagram, okay, class, the given. Take a look at the given and see what we can do to come up with the answer.
Tangent of 20 degrees.
Tangent of 20 degrees equals?
B over 200.
Beautiful. I hope you see that. Believe it or not, the hardest part is setting it up. The hardest part is the diagram. So with that being the case, generally speaking, we're going to write tan of theta is B over A. And then we plug in what we have and we find the missing. So what do we have? We have theta. What do we have? We have A. So what is B? V is the product of the two. So it's 200 times tan of 20 degrees. It's the cross product. Everybody, again, everybody knows this. This is the cross product, okay? So V is 200 tan of 20 degrees. Now you use a calculator and you end up with 72.79 meters. Don't forget, you always use the decimals unless you're asked to round it, okay? So you want to use a bunch of decimals. So I hope you appreciate the really neat application of what we have just discussed in this section. Sounds good? All right. I'm going to pause the recording, class. All right. So we do have applications. So we saw applications involving what surveyors do. Okay. And now other applications. There's something called an angle of elevation. There's something called an angle of depression. Okay. Anybody want to read this definition for us, class? Could somebody read the definition, please? Everybody can participate, class, if you're interested in reading for the class. I appreciate that.
Okay, I'll read it. Angle of
Thanks.
elevation is the angle formed by the line of sight in the horizontal plane for an object above the horizontal. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal.
Okay, thank you so much, Anna. So I have put a bunch of, diagrams for you so it becomes clear. In short, you will always make up an angle with the horizontal line. If we are looking up, in essence, becomes an angle of elevation. If we are looking down at an object, becomes an angle of depression. That's as simple as that. Does that work, everybody? So we are always comparing it, if you will, to the horizontal line to figure out what's the angle of elevation or depression. All right, so having said that, let's go to see an example. All right, anybody else want to help us? Anybody else want to get?
I'll do it.
I appreciate that. Thank you so much, Mercedes. Go ahead.
Meteorologists find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. A ceilometer was set up such that its light projector is 300 feet from its projector. If the angle of elevation of the light detector is 75 degrees, find the height of the cloud.
Thank you so much. So class, again, another application of that, okay? Fascinating stuff. I hope you find this stuff fascinating. And the hardest part is really the setup or coming up with the diagram if the diagram is not available and you are supposed to do it on your own, okay? So first, the setup, as you can see, is such that it generates a base distance, okay, from where you're looking at the height of the cloud to find and the angle, okay? And so if we were to put all of this information into a diagram, it gives rise to the following diagram. Do you see that, everyone? So we have the base is about 300 feet. It makes an angle of elevation of 75 degrees. And all we have to do, find the height using one of those trigonometric functions that is easy to use. So with that being the case, I hope everybody can see, based on the given information, the easiest trigonometric function to use would be tangent. Therefore, we use tangent. Theta is the opposite over the adjacent, or h over b. We replace the theta with 75 degrees. And h is simply the cross product again. I hope everybody knows that. And excuse me, using an approximation with a bunch of decimals, we can come up with the answer. That sounds good? All right, class. Perfect. All right, so we are looking at applications of this stuff. I'm going to move on. Here's the next one, class. Could somebody read this question for us? I hope everybody is excited to be participating. Anybody else want to participate and help us, class? Go ahead. Let me hear from someone else in class, please.
A statue of Ceres, the Roman goddess of wheat, can be observed at the top of the board of the Trade Building in Chicago. Observations 400 feet from the center of the building reveals that elevations to the base and to the top of the statue are 55.1 degrees and is 56.5 degrees respectively. What is the height of the statue?
Thanks, Amy. All right, perfect. So what's going on here? Okay, again, it is fascinating. I hope you find it fascinating that, you know, you can find the height of the statue without being there and actually measuring it by using this methodology from trigonometry. Okay, so all we have to do, we have the measurements. The base is 400 feet. Okay, so we can use one of the trigonometric functions and deal with the angle of 56.5 and find the height. And then another one with the angle of 55.1 degrees and find the height. And I hope you see the difference is the answer. In other words, take a look at these two, okay, setup. So the base is 400 feet. So 55.1 degrees okay, versus 56.5 degrees, okay? 55.1 to the base and 56.5 to the top. So the easiest way, again, just the given information results in using a tangent. I hope you see that, okay? So it makes sense to use the tangent here. So with that being the case, when we use the tangent, we see that tan of 55.1 is the opposite, which is called B here, or you can call them H1 and H2. And so B over the base or the adjacent or 400. You're practically done with this part, because how do you find B? You do the cross product. Let me, again, 1 times B, 400 times tan of 55.1 degrees. And that results in roughly 573.39 feet. That would be the height to the base of the statue. In essence, maybe the height of the building, if you will. Now we do the same thing using tangent of 56.5 degrees. And now, this time we call it the new height B prime, if you will, over the base 400. Base or adjacent, if you will. And again, it's the same cross product that you've seen. And so the case gives you what? 400 times tan of 56.5 degrees. A rough estimate, okay, with a bunch of decimals, gives you 604.33 feet. So that is the height, in essence, of the building plus the height of the statue. So what is the height of the statue? Would be the difference between the two heights. So you subtract B from B prime, and you get to the answer about 30.94, about 31 feet. Sounds good? Everybody okay with that? Is there a question, class? So I hope this is very straightforward. Okay. We are ready to move on. All right. I'm assuming we are okay with this class. So we are going to look at a lot of applications from here on. All right, navigation and surveying. So we are going to look at direction or bearing. Can somebody read the definition of a direction or bearing for us, please? Somebody else going to help us here, class? I know. Yeah, go ahead, Mrs. Thank you.
The direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction from the north vertical line to the line joining the center of the compass with the point. In other words, direction of bearing of a point O to a point P equals the acute angle between the ray OP and the vertical line through O, the north-south line. A bearing is used to represent the direction of one point relative to another point.
Thank you so much. Now, what I want to mention is two things here. There are two ways. Number one and number two are different. There are two ways that they look at bearing. Sometimes the bearing is simply with respect to one direction, north, period. So they look at the north and they do a clockwise measurement of the angle, and that's it. But what we are going to do here is really number two. I want you to pay attention to what we are going to do here. Number two says, it's not respect with north, but rather north-south, meaning what? The way we will mention it, we will start with either north or south, okay? Which one? The one that if it's closest to north, we start with north, the point we want. It's closest to north, we start with north. It's closest to south, we start with south. Okay? Now, just as an example, so everybody understands what we are trying to do here, okay? Just as an example. When we look at P1, everybody, P1, is it closer to north or south?
North.
North. I hope, okay, if I were to draw something, do you see that this would be the angle, okay? But if I wanted to go with the south, this would be the angle, okay? So what are we looking at? The closer of the two. All right, so far so good. So therefore, we're not going to use S, we're going to use N, north. Good. The next thing we mention is the angle. So what comes after N or after S is the angle. The angle reads 30 degrees. Agreed? So next, 30 degrees. Then, is it on the right side of N or on the left side? If it's on the right side, it is considered east. If it's on the left side, it is considered west. Is that making sense to everybody? So for example, for P1, we write north, we write 30 degrees, and it's on the right side, we write E for east. Does that make sense to everybody? So we are using the second method, okay? Again, the first method just looking at north and comparing it to north. This method just compares it to both, either north or south. Which one? The one that is the closest. Okay, I want to make sure everybody is comfortable with the concept, okay? Now, the next thing is we are looking at the next point, P sub 2. As we look at P sub 2, okay, is it closer to N or S? P sub 2 is closer to N or to S? Which one?
S.
S. So we start with S. If it's closer to S, then we look at the angle that it makes with S, which is given as 50 degrees. So we write S, we write 50 degrees. Now, is it on the left side of S or the right side of S?
Left.
Very good. So because it's on the left, we say west. So south, 50 degrees west. I assume everybody is comfortable with this. So let's give everybody a chance to write the remaining 2 points in the same manner. All right. What happens in the case of the next point, P sub 3? What's the answer?
North 70 west.
Very good, because it's closer to north. Right, class? makes a 70-degree angle, and it's on the left side, so it's west. Finally, P sub 4. What would be the answer for P sub 4, everybody? Anybody want to share with us?
South 20 degrees
20
east.
east.
Very good. Very good. So south 20 degrees east. So I hope everybody is okay with that. It's really not that big of a deal, okay? But uh, this is a concept known as bearing. So I hope we are okay with that. So if you've heard it before, in case it didn't make sense to you, now it makes sense to you. I'm going to go to the next example, class. I'm going to go to the next example. And again, there are two different methods, okay? There are two different methods. So this is what we have, all of them written, okay? So what we just had in any event. Could somebody read this question for us, students? Everybody can participate. I appreciate that. I'm sure you're tired of hearing my voice. I know I am.
I'll
An
read it.
airplane takes off from a runway which has a bearing of n 20 degrees east. It flies for 1 mile and then the pilot requests permission from the control tower and turns 90 degrees, heading towards the northwest. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft?
Thanks, Talia. That was great. Okay. Before we go over that, let's see if you can figure this out on your own, because believe it or not, the hardest part is the setup. So what I'm going to do, I'm going to stop for about a minute or two. See if you can figure out the diagram that you need to come up with, and then we take it from there. So let me pause the recording. All right. Let's see what we notice. So we have this grid, if you will. In essence, it's just like a grid. Okay. Directional grid. North, south, west, east, or east, west. So as it takes off, the bearing is north 20 degrees east. So this is the direction that the airplane takes as it takes off. And it goes for 1 mile. So it flies for 1 mile. Then what happens? Then the pilot requests permissions from the control tower and turns 90 degrees heading towards the northwest. That would be the direction now, northwest, with a 90-degree angle. So this is how it looks like. Let me just go back. So we are going 20 degrees, okay, north 20 degrees east for 1 mile. Then we make a 90-degree angle, okay. And it will look like this, and we keep on going. So after 2 miles, now we are at a new point, let's say Q. What bearing should the control tower use to locate the aircraft? So I hope you see that. Now we are going north. Okay, so we are going, so this is the angle. So north, the angle, which we don't know, west. Okay, let me just north. So this is the answer. We should figure out the, it doesn't look good. Let me just north. So I don't know if it got any better, but you get the picture. So this is the answer. North, we need to figure out the angle, and it's west. Okay. So to do that, we can look at the given information. Okay. And we see the theta, the angle that the OQ makes with OP, the total angle of theta, can be found using the information that OP is 1, right, class? OP is 1, and PQ is 2. So tan theta is the opposite, which is 2, over the adjacent, which is 1. Does that make sense, everybody? So the opposite is PQ over the adjacent, which is OP. 2 over 1. So what is theta? So therefore it's equal to 2. So what is theta is tan inverse of that. Why do we write tan inverse of that? Because it is not a common arc. Therefore, to find it, we need to use a calculator. So that's why tan inverse of the 2, we put it into a calculator. It gives us 63.4 degrees or so. So what is the angle that we want? The whole angle theta is 63.4. And we know the little angle, if you want to call this alpha, if you will. So we really want theta minus alpha, and alpha is 20 degrees. So 43.4. So everything is done north. We didn't have the angle, we just found it. West, and we write it as north, 43.4 degrees west. So this is the new bearing, if you will. Does that make sense? Is everybody okay with that? Any questions? I think we are ready to move on. And we are looking at a lot of interesting applications, and of course, more applications are coming our way. Okay, class? More applications coming our way. All right. So here's the next one. We have a couple of examples here. So let's start with the first one, completely ignore part B. Let's look at part A. Could somebody be kind enough to read it for us, please?
A security camera
mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall?
Thank you so much. Okay, this is great. Okay, class. Now, the most important part is to be able to set this up. If you can come up with a diagram, practically you're done. So we have a security camera. which is 9 feet above the floor. We are needing a depression angle, which we don't know what it is, such that it will be directed at some spot that is 6 feet from the floor and 12 feet from the wall. Okay. So let's look at the setup. If we could figure out the setup, we are practically done. I hope you realize anytime you do applications, number one, it's important that you do the proper translation. And if it requires a diagram, you have to come up with a diagram so it works out. So take a look. Here's the diagram, okay? We are looking at the following situation. The camera is 9 feet above the floor. That's a wall. Right at top is the cabin. It has to look at some point this point is 6 feet above the floor. With this distance of 12 feet. So what is the angle of depression? So we are looking at this angle, okay? We are looking at this angle, okay? Remember the angle of depression and elevation, it always makes the angle with the horizontal line, okay? So I don't want anybody to be confused with the other one, okay? So that's the angle that we need. And that's an easy calculation. Tangent will do the job, is the opposite over the adjacent. Because this is 9 feet class, and we know this is 6, then this must be 9 minus 6 or 3. So we should calculate that if in case it's not given again. With the diagram that you make up, you should be able to figure out this number. So this is 3 over 12 or 1/4. Now, again, it's not a common arc. You just put it into a calculator. It's a tan inverse of 1/4, and there you have it, and you're done. Sounds good? Any questions? All right, let's look at the last question we are going to do in this section. And by the way, I do have a few more questions. If you have time, you want to study them, okay? There are a lot of questions that I came up with, and I hope that those are helpful. All right, the next one. Could somebody read part B for us, please? The last question. Could somebody read that for us, please?
Yeah.
Sorry. A straight tail with an inclination of 17 degrees leads a cottage at an elevation of 9,000 feet to a mountain peak at an elevation of 11,200 feet. Find the length of the trail.
Thank you so much. So again, everything is about setting up. If we can set this up right, you should have no problem, okay? So we have a 17 degrees of inclination, okay? The place that we are interested in, the cottage, is itself at 9,000 feet, okay? And the mountain peak is at 11,200 feet. You're going to find the length of the trail. So it's all about setting up. It's all about setting up. So if you can come up with the diagram, practically you're done. So notice, this is how it looks like. This is where the cottage is, at 9,000 feet. And then when you subtract 9,000 from 11,200, it gives you 2,200. So one more time. The cottage is at an elevation of 9,000 feet. Okay. The mountain peak is at 11,200. So that means from where the cottage is all the way to the peak, the difference of 2,200 feet. Okay. And that makes a 17-degree angle. We are interested in finding X. Okay, find the length of the trail. We're going to find the value of X. And again, as long as we can have this diagram, we are almost done, because the hardest part is to come up with this proper diagram. And as I've mentioned before, class, you do have 6 trigonometric functions. Try to use the ones that will work with the given info, not something that you have to come up with. Okay. So as you can see here, by definition, sine is the opposite over the hypotenuse. So sine of 17 degrees, okay. Sine of 17 degrees is the opposite, which is 2,200 feet, over the hypotenuse, which is x and is missing. So how do you find x? X is therefore 2,200 over the sine of 17 degrees, okay? And using a calculator, you come up with roughly 7,524 feet for 7,524.67 feet. That would be the rough estimate of that. All right, that works. Everybody's okay with that? Any questions regarding this page? All right. I'm going to pause the recording because this is the last question we're going to do. I'm going to spend some time talking to the students. So I'm going to pause the recording.